Okay, physicists, today we are going to use the photogates to measure the acceleration of an object. This will be our first chance to just kind of get a feel for how do you use the photogates to make this calculation of the acceleration. Now, of course, we're going to measure both the initial and the final velocity, and we already know what the distance between the photogates is. But it would be kind of boring to just measure the acceleration one time. You've kind of already seen that. I've already shown you the data for that. So instead, we're going to do a mini experiment. Nothing fancy. We don't have a big write-up. There's no procedure we have to worry about. We're not going to worry about analyzing the data too deeply at the end. I just want to understand in a simple way what happens to the acceleration of a car, a little toy car, as I make the ramp that it's on a little bit steeper. I'm sure most of us can agree that it's probably going to go faster. The acceleration will be greater as I go steeper and steeper. But the question is, if I move that ramp up in nice even increments by using books, will I find that each book causes it to increase its acceleration in a simple mathematical way, or is there a little bit more complicated mathematical relationship there? And so it's just going to give us a chance to collect the data. We really just want to calculate the accelerations. I don't really care what the relationship is with the ramp. I just want to practice making the data tables, collecting this data, and seeing if we can come up with anything. Let's see if the graph shows us any kind of relationship between the angle of the ramp and the acceleration that we get from that. So before we go back to the back and start collecting the data, let's think about what data we're collecting. So remember, the initial and the final velocity, and then the distance. So those are definitely going to be column headings in our data table. Now, I'm not putting any units on these, but of course these do have units. You do want to make sure you put the units on them. And it's your choice. You can actually write the word out, or this is a common symbol in physics. Anybody would understand who is reading at this table, who is a physicist. And you should expect that somebody who's reading your work has some expertise in physics, and they'll recognize what you mean when you say this. This is the initial velocity. This is the final velocity, and that's the distance or the displacement. It's this problem, those are essentially the same. What's the thing that we're looking for? The acceleration. So remember, everything will be in meters and seconds. So speeds in meters per second, distances in meters, acceleration will come out in meters per second squared. Meters per second squared on the acceleration. We'll collect for several different elevations. So what I'm going to look at is how does increasing the number of books underneath the ramp, how does that affect the acceleration? So eventually what I'm going to want to do is to make a graph of the number of books versus the acceleration at the end. This will give you a great chance to practice working in Google Sheets again and just get a little bit better at handling that data. So let's head to the back and let me show you what I've got set up. So the first thing that I'm going to do is to actually test out the cars and see which cars behave and which cars misbehave. Because there are certain things I don't want to see happen in this. All right. So I have a number of toy cars, but before we get started, let's give them all a push and just watch how they move. Okay, I don't like that guy at all. That guy is out. Not bad. He's in the maybe pile. Oh, awful. I don't think that was very good. Not terrible, but not good enough. Maybe. Oh, that guy looks really good. I'm gonna put that one over here in the corner. That's the best one so far that I've seen. That guy wiggled. Too much wiggling. Last guy, oh, it starts backwards. Okay. So hopefully you've kind of figured out what it is that I'm looking for in the cars. I really like that car. That one's not bad, but I do feel like that one is not as good as the other one. So let's get rid of our cars. And this will be the car for our experiment. So here is our ramp. It's just a piece of cardboard. I'll put this guy over here. And we'll move the camera a bit so that you guys can see more clearly what's going on. Okay, so I have right now, I'm going to put this guy, so the initial velocity will be up here on the front end where the guy is going to come in, and then the final velocity will be here. After I collect this data, remember, record this right now. The distance is 0.059 meters for every measurement. So we don't need to write that 100 times. You can just put an arrow on your paper table as you're recording this data, or if you want to go ahead and put it into Google Sheets, just put it in that first cell and drag that guy down under the distance column. Okay, so what we need is these two. Okay, and just to make sure everyone understands what's going on, they're blinking right now, which means that they're ready to go ahead and start making the measurements. All right, our first measurement. All right, guys, here we go. So the initial velocity is 0.23 meters per second. The final velocity is 0.34 meters per second. Okay, that's for one book. Right now, I have one book under there. Let's see what happens when we go to two books. So just to remind you, initial velocity 0.23, final velocity 0.34. Okay, everything is set up. I can see both of the lights are blinking. We'll set this guy up to go through book number 2. All right, here we go. The initial velocity is 0.33 meters per second. The initial velocity. The final velocity, 0.49 meters per second. I'll do that again. Initial velocity 0.33, final velocity 0.49. All right, book number 3. Let's raise up the ramp a little bit. Okay, so now the photogates are not going to stay in place, so I'm going to hold them in place while we do this. All right, here we go. This is for 3 books. 0.41 for the initial velocity, V naught 0.41, final velocity 0.61 meters per second for the final velocity. All right, last book. Okay, I know this is not going to stay in place. That guy's going to slide quite a bit, so I'm going to hold those in place. Everything is all set up. I can see that the lights are blinking. All right, there we go. Last measurements. Initial velocity, 0.44. Initial velocity, 0.44 meters per second. Final velocity, looks like 0.67. 0.67. All right, guys, let's see how the data looks. We may find the data turns out great. We see a simple relationship, or we might see the data's all over the place, and maybe our measurements weren't that great, and we maybe need to redo this experiment. So you go ahead and work on those data tables, produce that graph, and remember, this is really just a practice to learn how to measure acceleration using this device. We're going to do this again in a few months when we get to the forces, and you're going to have to use this exact same device to make the measurements, and it's going to go exactly like this. I'm going to show you the velocities. We'll always have the same distance, and you'll be able to calculate the acceleration when we start looking at forces. All right, guys, good luck with that table and graph.